Hey everybody, today is Wednesday, September 14th. Our objective today is I know what active reading is and how to annotate an article. So we're going to finish up Geology on Mars, actually a little bit from yesterday. We've got just a couple more things to talk about in lesson 1.2, and then we're going to skip 1.3, and then we're going to go straight to 2.1, so chapter 2, activity 1. And we're going to be working through activities 1 through 3. Inside this folder is a copy of an article that you're going to read, and I don't think that I have very much time for the kids to read this, so this is really truly homework for you. You're going to finish reading and annotating this article, and I'll remind you towards the end of the video today. But if you open up this folder, the article is called Investigating Landforms on Venus. And so go ahead, if you would please, and copy this into your GOM folder, your Geology on Mars folder. It is a 2-page article, okay? And you're going to read and annotate that, and I'll talk to you a little bit more about that in a minute. Go ahead and stop the video. Copy the article into your Geology on Mars, and then go ahead and start the video up again. Okay, let me go ahead and get to the very beginning here. So we are going to pick up, if you were in period 1, we talked about this, but if you're in periods 2, 4, and 5, I ended class yesterday with you guys just doing a little bit of exploration of Google Mars, where we're just looking at that one satellite picture. And mainly what we were trying to do is see if you could identify landforms that you think were formed by flowing lava or flowing water. And so we talk a little bit about what a landform is. And again, this is a vocab word that you should be familiar with. It's a feature that forms on the surface of a planet, such as a mountain, a channel, a sand dune. These are all examples of a landform. So we spent some time talking about what the kids saw. A lot of them identified this right here as a possible canyon. We talked about reminding each other that a higher elevation was white, and then it went down to red, and then orange and yellow, then blue and green. So you can see that there's a very significant drop in elevation as this almost cuts through the land. And a lot of people thought this was formed by water, but then some people thought that this was formed by a volcano, and actually lava formed this, because we've got this gray area here that this seems to be coming off of. And we know that gray is a higher elevation, and then these 3 landforms are actually volcanic mountains. And so we're kind of wondering if maybe this was all volcano. A lot of people kind of pointed out these structures here, and when you zoom in, you could really see the different cuts. It almost looks like part of the sides were eroded away, and so lots of argument about whether that right there is formed by water or formed by lava. A lot of people also talked about how this was really narrow, and so they thought it was water because it was very narrow. But again, we just weren't quite sure. So then moving on, I want to talk to you about what our anchor phenomenon is. So there's a specific landform on Mars that we're going to pay really special attention to in this unit, and it's called a channel. And a channel is a long, narrow groove that forms where water, lava, or other liquid flows. And so here's a picture. If you go into lesson 1.2, go to activity 3, screen number 2, and you can see a really good close-up picture. My screen cuts it off a little bit. But this is a channel that the geologists found on the surface of Mars. It is not in this picture at all, so don't try and find it. It's not there, but it really is on the surface of Mars. And we're trying to find out if the geologic process that formed this was formed by water or by lava. And so that is your role as a student planetary geologist. We're going to be doing a lot of investigations. We've got some hands-on activities Thursday and Friday of this week. where we're going to try and recreate this and kind of see if, just by using a model, if we could see what we think caused that. If you go to our chapter 1 question, remember we're just talking about which geologic process could have formed it, either flowing water or flowing lava. In order to find out more, I just told the kids we've got to do a little bit more investigation. So one thing that we did is I gave the kids these two background information. They're like cards, and they had pictures of geologic processes of flowing water and flowing lava. And the interesting thing is, I think immediately in this picture here, the kids wanted to say this right here definitely was water. It's a canyon made by water. And if you look at the pictures here, you might be able to identify this canyon, and you can say, okay, it was formed by flowing lava. We've got those steep sides of the canyon where this river kind of carved out this steep canyon. But if you're really careful and you make a lot of really good observations, you can see that this river here does not have steep canyons. And so just because there's flowing water doesn't mean that it's going to have these steep canyons. And then this one, although this picture and this picture show a narrow river, this picture kind of shows a wider river, and it looks like the sides are a little bit more jaggy. Okay, so that's water. But then when we look at the geologic process of flowing lava, oh my goodness, look at this. This is a lava flow, and it's also long and thin. We could also have this kind of like branching of lava, and then it sort of pools down at the bottom. If the elevation flattens out, then all that lava kind of collects there and forms this like fan. Okay, this is a picture of just a really gnarled lava flow, and then this one is just very wide and not very narrow and straight. And so this kind of resembles this water flow. The purpose of looking at these cards is because I wanted the kids to really understand when you're making scientific observations, it's good to use all of your senses, but be careful that you don't just use one sense, and in this case it's what we see, and be quick to make a judgment based solely on that. We need a lot more information, okay? So we've got a key concept number 2. So go to your key concept graphic organizer in GoodNotes. If you don't have one, everybody should have one. I think I was very specific in checking, but just in case you don't have one, if you go to Monday's folder, we've got the Geology on Mars graphic organizer for your key concepts. We did number 1 yesterday, and so key concept number 2 will be written right here. And so this is key concept number 2. When landforms on different rocky planets look similar, it is evidence that they may have been formed by the same geologic process. So in other words, if we can look at this picture here on Mars, and we can say, okay, this is similar to what we see on Earth, then maybe the geologic process, in fact, we can say pretty certainly that the geologic process that formed it on Earth also was the same geologic process that formed it on Mars. So the idea is, if we're trying to figure out what planet can sustain life, and we're looking for a planet that may have had liquid water on at one point, if we can prove that that channel was made by liquid water, then we definitely may have a reason to look at Mars for evidence of past life or bacteria that was on there. So I want you guys to pause the video and write down key concept number 2. Okay, lastly, we took an article investigating landforms on Venus, and we are going to be practicing active reading. And I talked to the kids a lot about, remember, we've got 2 claims. What geologic process could have formed the channel on Mars? And claim number 1 says it was water. Claim number 2 says it's lava. We need to find out more information, just more than what we just can see, and making comparisons of photographs that we see on Earth. Our chapter 2 question is, how can we gather more evidence about whether lava or water formed the channel on Mars? And we're going to be doing active reading. I'm going to show you this slide here real quick. When you are reading actively, it means that you are present while you're reading. I know it comes a little bit of a shock to you. Sometimes scientific articles can be a little bit boring, and sometimes you get a little distracted, and maybe you read a paragraph and then you go, wait a second, what did I just read? So active reading is a way for you to make sure that you are engaged with the reading constantly, and so you don't have an opportunity to space out, and it helps you to just kind of restate or summarize what you just read, so you can so you know what you read. You don't get done with the whole article and go, okay, I have no idea what I just read. So when I talk to you about annotating, I'm going to show you a big picture. This is an example from a different article. And annotating a text means that you're recording your own thinking as you read. So I think I talked to you guys before, if you've got some vocabulary words, like we've got landform, we've got biosphere, we've got geosphere, we've got channel. We do have some vocabulary terms that might show up in the article that you're going to read for today. And so you might want to pick one color of a highlighter and highlight those vocab words, and then pick a different color. And this is what you might highlight and go, oh, okay, this is really important. Here's the difference between just highlighting an article and annotating an article. If you highlight an article, but then you don't write anything in the margin, then you're not going to remember why you highlighted that. And so tomorrow, when we go to talk about the article that you guys read, I'm going to ask you some questions, and you're going to end up having to kind of skim over the article all over again, because you won't have any clues that you wrote to yourself as to what you read and what you thought. So annotation is writing these little notes off to the side. As you're reading, if you read something and you're like, oh, okay, that makes sense, and you highlight it, or you think, okay, this is an important piece of the paragraph, this is a main idea, or this is an example, I want you just to write yourself a quick note off to the side as to why you highlighted it. We talked about systems, and so here's an example of a system. And see, notice how this person highlighted system and then drew an arrow out, and this is what they were going to explain. Go ahead and even make notes in your graphics that you see. Ask yourself questions, and when you get the answers, draw an arrow down to say, oh, okay, here's the answer. Underneath the graphics, there's captions, and the graphics are meant to support what you read in the text. And so it doesn't really matter if you want to look at the graphics first. I'm going to be honest with you, as a visual person, I end up reading, or I look at the graphics first and I read underneath them. And then when I read in here, I go, oh yeah, that's what this was talking about. And so a lot of times I'll highlight something in my text and then draw an arrow over to the graphic, because I'm like, that's what the graphic is showing. Some people like to read the text first and then look at the graphics and then go, oh, this is where I read that. Whatever you want to do, this is your note-taking strategy, and no two people are going to have the same annotations. That being said, people are going to ask me, how many annotations do I need to make? This is a really good example of an annotated page. I want you to write this thing up. I want to know, what were you thinking as you read the article? Okay? So make sure that you read, highlight, annotate the article. Let's see. And that's it. That is homework for you guys for Thursday. We're going to discuss this article, Investigating Landforms on Venus. I know you guys can go and find the article Investigating Landforms on Venus in in Amplify, and that you can read and that you can highlight and that you can add notes. I would prefer that you don't do that. I want you to either have a digital copy in your GoodNotes article, or have a hard copy. And since you were absent today, the digital copy is about the only thing I can offer you. it's important for you to have that, because in Amplify you can read and annotate, but then that article is kind of lost to you unless you go back through and really search for it. And I want you to be able to go to it if, in 3 days from now I want to reference the article again. I may say, hey, you guys, go to your notebooks and pull up that article. Let's talk about something that was in that article. And so I want you to have it handy and not have to go through everything with Amplify to try and find it. Okay? All right, let me know if you have any questions. I hope that you are feeling better, and I hope to see you on Thursday. We've got a hands-on activity. It's a lab, and so if you are absent on Wednesday, but you're going to come back on Thursday, make sure that you are dressed appropriate, and I hope to see you on Thursday. Okay, bye.